Here we have two chords of a circle that intersect. The red chord has lengths A and B cut off by the blue chord. The blue chord has lengths D and C cut off by the red chord. If we multiply the length of A by the length of B, we will get the same value if we multiply C by D. So these two products are always the same, no matter where the chords are. Of course, we get different values for the actual products. It's just that both of these products give this same value. To prove this result, we connect this point to this point here and this point down to this point here. Note these two angles up here, which I'm calling D and B. Both of these angles stand on the same arc, namely this arc here, which I've highlighted. We know from a previous result that angles on the same arc are equal. So D is equal to B. In this case, D is 50.53 degrees. Note these two angles here, E and F. These are opposite angles. And we know from a previous result that opposite angles are equal to each other. So we see that if we take both of these triangles, two angles in them are the same. And if two angles in two triangles are the same, then the triangles are similar triangles. All three angles are the same. So that means that this angle here is equal to this angle here, because the three angles in a triangle add up to 180. So if we know 2, we automatically have the third angle. As a matter of fact, we could show that these two angles are the same by noting that they are angles standing on the same arc, namely this arc here. So these two stand on this arc. But we don't need that. We just need to show that 2 are the same. Now, we know that if triangles are similar, then ratios of corresponding sides are the same. So let's look at corresponding sides. Let's look at the side opposite angle D. Well, the side opposite angle D is small d, and we need the side opposite angle B. So D and B are corresponding sides because they're both opposite the same angles. Angle D equals angle B. So if we take the ratio of these two sides, we get D over B, or we could write B over D. It doesn't matter, of course. But the numerator of the ratio, or the fraction, is a value from this triangle. So now we need another pair of corresponding sides. So now we need to look to these angles here. We know that they're the same, of course. So we need to go back to this and take the side opposite this angle, which is A, and divide it by the side opposite this angle here in the other triangle, which is C. So we have D over B equals A over C. Now, since we have a single fraction on either side of the equal sign, all we do next is cross multiply. A multiplied by B equals C multiplied by D, and that's the end of the proof.